Assalamualaikum and hi to all the viewers of this video and to the fellow Viva panels for the final year project in University Technology Malaysia Skudai Johor Bahru. My name is Umarul Aiman bin Ramli and I am going to be presenting my final year project title, that is the effects of nitrogen gas on flame propagation of natural gas combustion. So moving on to the problem statement, what is the effect of the increase in composition of nitrogen in natural gas combustion in terms of burning rate and masking length? Um, in this research, we want to determine the effect when we increase the composition of nitrogen to determine the values that have been derived when we change the composition of nitrogen in terms of its burning rate and masking length. And second is, what are the other components that can contribute in varying the flame speed and flame stability of natural gas. Besides the composition of fuel, there are other factors that contribute in increasing or decreasing the burning rate or the masking length, such as the equivalence ratio, the initial temperature, and the initial pressure. So the objective of this research is to investigate the effect of nitrogen gas on spherical flame propagation of natural gas combustion in terms of flame structure and burning rates. So the main focus of this research is only the spherical flame propagation, as we will not further detail in the research of the flat flame or the counterflow flame. So this is the scopes of the this research, that is the initial condition of combustion is set at 323 Kelvin and 0.1 MPa. As you can see from this, temperature is slightly higher than the standard room temperature, because we want to achieve the temperature at the inside of the internal combustion engine, which is set higher than the room temperature. Thus, we can show that the result of this research can contribute in the internal combustion engine. So the second scope is covering only lean fuel admixture at equivalence ratio of 0.7. This is to achieve the best fuel economy of combustion properties. And the third is using typical composition of natural gas from local refineries, such as the methane, ethane, and nitrogen gas. Moving on to the literature review, natural gas represents one of the best alternatives to conventional petrol fuel, since it's producing significantly lower emission and particulate matter, such as the particulate matter and oxides of nitrogen. Natural gas contains mainly methane, which is composition around 70 to 90% compared to other composition in the natural gas. This shows that the combustion properties of natural gas is mainly affected by the composition of the methane gas. The composition of natural gas varies widely from one source to another in terms of higher hydrocarbon, that is around 7 to 16%, while N2 CO2 are present in 20 to 25% maximum. This shows that when we vary the value of the inert gases, such as the nitrogen gas, it can contribute main effect into the burning rate and the masking rate. So this is the average composition of natural gas in Peninsular Malaysia, gained by Energy Commission in the year 2016. So our focus will be on the gas composition of methane, ethane, and the nitrogen gas to their mole percentage. So this is nitrogen characteristics. Nitrogen is inert or chemically inactive if present in a large amount, which thus will quench the reaction zone by increasing specific heat and reduce the laminar burning velocity. Besides that, nitrogen is easily available and cost effective, and is said to be expected to widen in the future. So there are four methods of measuring flame speed, that is found by D.P. Mirsha. That is the combustion bomb method, stationary flame method, tube method, and soap bubble method. And the method that we'll be using in this research is the combustion bomb method. This is the figures of different types of method that can be used, but however, the methods of spherical flame propagation is only the soap bubble method and combustion bomb method. The methods of flame visualization is by using the Schlieren image, shadograph method, luminous interferometers, and chemiluminescence. And for this research is by using the Schlieren image. So this is schematic diagram of the types of methods of visualization, and the main focus is the Schlieren technique, where the combustion process take between the lens that is also having the camera and knife edge and also light source and slate. So moving on to the stretch rate and masking length. Masking length is the sensitivity of flame speed to stretch rate. So as we draw the stretch rate against the flame velocity, the flame speed, we can produce the trend line which shows the gradient of the trend line, that is the masking length. So if the gradient is positive, which shows in this time of trend, it shows that the flame is stable. Then if the flame shows the trend is round like this trend, this shows it is negative and it's not stable. Masking length called peripheral diffusion is one of the three factors contribute to the flame instabilities beside body force effect and hydrodynamic effects. So masking length shows the the flame is stable or not in terms of the magnitude and value. So this is the calculation of determining the burning rate, which is derived from the flame speed equation. So this, moving on with the methodology, this is the flow chart of conducting the experiment, which is start by vacuuming, gas input, combustion process, image acquiring, analyzing, and repetition of the different composition of the experiment. So this is experiment setup of the combustion bomb and Schillerian image combined together, which also the gas added is methane, ethane, and nitrogen. As you can see, the gas preparation is taken by the standard as ASTM-D3 standard and compared with the natural gas from Malaysia. This is the calculation partial pressure of fuel, which is first determining stoichiometric reaction to the stoichiometric equation, and then calculating air-fuel ratio, determining number of fuel for fuel, and then determining the partial pressure, which is the obtained partial pressure is through the mole fraction and the partial pressure equation, thus getting the partial pressure of methane, that is 0.0685 bar for pure 100% methane. So this is required software for image analysis, that is the Phantom Cineviewer, MATLAB, Photoshop, Glasec, and Microsoft Excel. This is the image processing analysis, which uses the high-speed camera to capture the flame propagation and then transfer into images, and the image will get into the MATLAB and turns into black and white, and thus producing data in terms of the radius and the time taken. Moving on to results and discussion. This is the development of spherical flame from different composition of fuel at different time after ignition for equivalence ratio of 0.7. So as we can see that when the value of nitrogen increase, the flame propagation, spherical flame propagation seems compared to the 100% CH4 and 90% CH4 plus 5% C2H6 is smaller than them. So this shows that a good trend might come out from this research, as based on the theory, addition of nitrogen will cause the burning rate to decrease. So this is code name for each composition, where will be used later in the graph. This is the variation of flame speed of different composition of fuel mixture with time after ignition for equivalence ratio of 0.7. So as we can see that the time taken for CH4 is shorter than the time taken for addition of 10% of nitrogen. So it shows that by adding 10% of nitrogen can cause the flame speed of the fuel emission to be lower, or burning rate to be lower. So this is the graph of flame speed versus time, which shows that the 100% CH4 shows the highest flame speed compared to the 10% of N2 shows the lowest flame speed. As we can see from this trend line, there is a slight decrease during the initial state of combustion, where then there will be increase back again until there will be oscillating trend line. This will be further discussed later. And also from this research, as we can know that adding nitrogen decreases the flame speed. However, for 100% CH4 and 95% CH4 should also be determined in terms of their properties of combustion. Thus, we will further detail in this research in the next section. So this is the initial spark effect, which can be shown previously as the lower minimum point occur during the initial flame combustion. This large drop is created by the shock wave propagate outward, followed by a smaller thermal wave. The thermal wave front usually has a high initial speed that rapidly decreases over a short period of time. So, moving on to the addition of ethane to methane, flame speed for as you can see before, the 100% CH4 is higher flame speed than P2N2, which is the addition of ethane um, to methane. This shows that this shows that this might have an error since this experiment might have an error since the addition of higher Hc hydrocarbon increases the laminar burning velocity, especially in lean or rich mixture. This is because carbon-to-carbon bonds have a significantly lower bond dissociation energy compared to carbon-to-hydrogen bond, and thus it is easier to break a carbon-to-carbon bond of ethane molecule. Thus, this might show that this research have an error in terms of the difference misconducting the experiment, or different in the initial condition have been used during the conducting experiments, such as the equivalence ratio, initial temperature, and initial pressure. As previously research have stated that increasing these three types of factors can contribute to increase highly or decrease highly the burning rate of the fuel air mixture. So this is the effect of acoustic wave disturbances. It can be acoustic wave disturbances is the disturbances occurs at the after the flame has been stabilized after the spark ignition during the initial combustion. However, the fluctuation is caused by the acoustic disturbances, which comes from an interaction between heat release and acoustic wave. Disturbances might also come from the combustion geometry. However, further details about the effect of oscillation of flame speed is beyond the scope of this study. So moving on to the spherical flame radius also shows that the same term as the flame versus time, which shows that after 10 mm, the flame speed shows quite good trend compared to the initial time, and this after 10 mm will be speed will be used in terms of determining the burning rate and the flame stretch to burning rate and the masking length. So this is the trend of the the flame speed over the stretch rate, and this will cause the determining the value or magnitude of the masking length. As we can know that this value of gradient is not showing the actual gradient of the masking length, as for masking length the direction of flame development is into the left, so the the magnitude will be slope will be like this to be producing positive magnitude of masking length. So from this graph, this shows that all composition shows the trend of positive masking length, that shows that all the flame of this composition is stable. So this is comparison between the previous works. However, from previous work we cannot determine the exact initial condition or method of experiment, which all of these variables can cause different values of the burning rate and the masking length. So this is comparison of masking length from the literature and current study at different composition of fuel. As we can see that this graph shows a good trend where increasing composition of nitrogen increases the masking length value, while for the burning rate, increasing the composition of nitrogen decreases the burning rate. Based on conclusion, in terms of effect of nitrogen composition, the increased composition of nitrogen causes the burning rates to decrease. This is because higher heat capacity has been mixed into the fuel, which causes total heat capacity to be increased, thus decreasing the burning rate, which is the thermal diffusion effect. Furthermore, addition of nitrogen also causes masking length to be increased, which follows the result of Liu and Hart et al. Thus, this research follows the trend of this previous research in terms of the increasing composition of nitrogen gas, in terms of their trend of burning rate, and the Mark Sting line. That's all from me. Thank you.